And this is the other part of the belly of the beast. I'm going to unlock the doors. Okay, so, here, this is performing the update based on the observed information. So, we have information we computed in on before step. What was that information that we computed? The job of that on before step, what did it compute? Yeah, how many live neighbors? N alive around. That's the number of ones right around me. In other words, if I'm here, how many around here are alive, right? It's either 0, 1, 2, 3, or 4, right? So, given that we already computed that, and where do we store that information? We stored it within our N alive, right? So it's still around, okay. So given that we have that, now we're going to determine what our liveness is going to be in this next step, okay? And we can do this with abandon because we don't have to worry that anyone else is going to be only counting up whether or not we're alive now. Everyone before this step has done their computation, what they need to know to determine whether they're going to be alive or dead. And now we're going to actually do it. So they've already computed there. Every cell around me has already computed their N alive around as well, right? Does that make sense? Does that make sense? So, in other words, in on before step, I'm computing how many neighbors around me are alive. This guy is computing how many neighbors around him are alive. This one is how many neighbors around her are alive. How many neighbors around her, how many neighbors around him are alive. They're all doing that in on before step. So they are no longer, if I update myself, it's not going to throw off their calculation. Okay. So now we can each of them can compute. So they have, so for a given cell, we consider how many neighbors around it are alive. We consider its current liveness status, and on the basis of that, we update it. And the rule here is put out in a somewhat complex form here. It's put out in a succinct form. I think it could be done a little bit more clearly, but I'll explain it. But the big picture thing is here. This is being assigned to because we're updating whether or not we're alive. That's our only aspect of state. It's updating it based on our current liveness to this point and the state of those around us. That's the big picture. The details of the rule are such as specified here. An alive cell stays alive if and only if it has 2 or 3 alive neighbors. If it's 1 or 0, it's too few. It'll die. If it has 4, that's too crowded. It will die. Okay, so if we're currently alive, and then, well, a dead cell becomes alive if there are exactly 3 neighbors. So there's exactly 3 neighbors, we're alive, right? We're going to be alive, whether we're dead or started alive. So if we have 3 neighbors, we're going to be alive in any case. And actually, so conceptually, this is a logical OR. This is saying if either, so this is a true or false thing. We're either alive or we're dead. And if we have 3 neighbors, we're definitely alive. So if this or this is true, we're going to be alive. So if we have 3 neighbors, we're alive. If we don't have 3 neighbors, well, it's going to be considering this condition here. And this is saying, okay, either you have to be greater than or equal to 2 and less than or equal to 3, based on that criteria, or you have to be and you have to be currently alive. So you're not going to, unless this is true, you're not going to be, if you're not alive already, you're not going to become alive. The only way you're going to become alive is this latter one is true. But if you're currently alive, okay, you're going to stay alive if you have at least 2 neighbors and no more than 3. Does that make sense? Mm-hmm. Okay. Very terse. You can write this as an if-else. If then else. So if, you're currently alive, then So here, this is again the ugly underbelly. Ugly because we have to do it in 2 steps. We have to collect all the information so we don't get thrown off if someone else updates before us, one of our neighbors. And then secondly, we have to do the update, and that's the update. And that is the bad side of discrete tar. We have to actually write that little bit of code, okay? And that's why I don't show that earlier. So this is the big picture, though. On this, we're updating our status based on information we gathered in on before step and our current status to this point. So that's on before step and on step.